What's good, Logan? I just thought I'd finish off some solving problems of quadratics using factoring. So when you're using the factoring technique, what you want to do is actually let's start off with why you would use a factoring technique. Factoring technique is really, really good when you can factor it, but you can't know that until you factor. The other reason you'd want to use it is when you have x squared and x in the problem. So when you see an x squared and an x, factoring is a really, really good technique to work with. So in problem 5, x squared and x, good technique factoring, x squared and 5x, good technique is factoring. If there was just an x squared, I'd suggest using like a square root technique. But I feel like if you have an x squared and an x, factoring, if it works, is fairly efficient. First thing you want to do is set it equal to 0. So I'm going to get the 48 to the other side of the equation. Very similar to the graphing technique. And this is going to give us x squared plus 2x minus 48 is equal to 0. What this does is it sets it up so that we can use the zero product property. After you do this, you want to establish what are the two factors of the lead coefficient or the lead term. That's x times x, or the quadratic term. And then you want to do the same exact thing, except this time we're going to do it for the constant term. That's 48 times 1. That would be 24 times 2, 12 times 4. Let's see, 6 times 8, so 8 times 6, and that, oh, I missed one, 3, can't forget that guy, 3 times, what is that, 16? So those are all the factors that we got. Now we're going to test the factors. The good news is since there's only one factor for x squared, we guaranteed that it's going to be x and x. Now we're going to take a look at what we want to do. We want to subtract. So when the c value is negative, we want to subtract, and we need to make sure that we can get a 2 somehow. Not necessarily positive right now. Don't worry about the sign of it, but subtract to get 2. So 48 and 1 probably not going to work just because of how far apart they are from each other. So 48 and 1, when I multiply, that's going to give us 48x and 1x. And when you subtract that, that's not going to give us that 2 that we need to get. So that's really, really far off. I'm going to kind of skip. If I try that with 24-2, that gets us closer, but not at all where we want to go. But if I look at 8 and 6, 8 and 6 are really close to that 2 right there. So we get 8x and we get the 6x. And then we want to subtract them, which will give us the 2. So when you subtract it, and then we look at it, right? We look at the middle, which is positive 2. So we want to start off with more positives. So we're definitely going to have the bigger number be positive. But then, since we want to get a positive 2x, we have too many positives with that 8, so we need to make sure that the 6 is negative. The 8x can only be positive if you multiply 8 times x, and the 6x can only be negative if you multiply the x times the negative 6. This right here is going to give us our factors. We set it equal to 0 because that's what it is, and now we apply the zero product property. So we take our first factor, our first number, which is x plus 8, we set it equal to 0, and we're going to solve that. And then we do the same thing with our second factor, or our second number, and we set it to 0. This gives us our two solutions, x equals negative 8, and x is equal to 6. So we have two answers, x is negative 8, and x is 6. All right, let's try that again. 3x squared minus 5x is equal to 2. First thing we're going to do, that's right, we're going to set it equal to 0, so we're going to take away the 2 from both sides of the problem. Take away 2 from left, take away 2 from right. This is going to give us 3x squared minus 5x minus 2 on the left side of the equation and 0 on the right side. That's going to set up a nice zero product property when we have this thing factored out. So we set up our factors. Actually, that's a little premature, sorry. Let's go ahead and factor the 3x squared. So we factor the 3x squared to 3x times x, and that's the only factor. So that means we know for a fact that that one's going to work, and 2 times 1. Ooh, really nice. There's only one thing that's going to happen, 3x and 2 and 1. We just got to figure out the right combination. So we set up our two parentheses, our two factors, set it equal to 0, and we're going to go 3x and x and 2 and 1. So I'll put a 2 here and a 1 here. And then I'm going to double check it, and I go, that's going to give me 2x, and that's going to get me 3x. And when I look at that, I'm like, oh, that gives me 5x. Oh, but wait, we talked about this in class. We have to subtract them to get the 5. Even though this 3x and 2x will give us the 5, it doesn't give us the 5x through subtraction like we need it to. That means what we did is not going to work. So we're going to take the 2 and the 1, and anytime it doesn't work, we just flip-flop it and put the 1 there and the 2 there. And now we're going to check these values. That's going to give us just x, 1x. 3x times 2, that's going to give us 6x. And if you subtract, right, because it says if you subtract 6x and x, you will get 5x. And that's what we want to do. Now, since we want to get a negative 5x, we're going to make sure that we have more negatives to start off with. So we're going to start off with more negatives. And then to get 5x, we need one less negative, and that's why the x will have a positive, so that they will cancel out that one extra negative. This will make the positive on the 1 and the negative on the 2, so that we get negative 6x. Now we can just set up our equations. 3x plus 1, the first number has to equal 0. 3x plus 1 has to equal 0. And the second number, x minus 2, has to equal 0. That's the zero product property right there. We're going to go in and solve it by subtracting 1 from both sides and dividing by 3, negative 1/3. And we're going to solve it by adding 2 to both sides. And we now have our two solutions, x equals negative 1/3 and x equals 2. Moving on, let's take a look at these ones. Find the zeros of the function. What this means, this is a new take on the problem. Find the zeros of the function. That's when f of x or y, right? F of x or y turns into 0. That's all it means. To find the zeros is when y is equal to 0. In other words, it's very similar to the graphing form or the graphing technique, except we're not going to graph it. We're just going to solve it. All right, so problem number 1, we're going to say x squared minus 9x. Instead of equals y, we're going to say equals 0. We factor it by factoring a GCF this time, since there is a common x. So we factor out the common x, and that's going to give us x minus 9. So we have x times x minus 9. You're going to set the first number equal to 0, which is x, and we're going to set the second number equal to 0, x minus 9. Now, when you solve x equals 0, that's pretty straightforward, and when you solve x equals 9, you add 9, and we have our two solutions, x equals 0 and x equals 9. All right, question number 8. We're going to do the same thing. Find the zeros. That means set the function 4x squared plus 28x plus 49. Set it equal to 0. Ooh, this one looks like a beast here. So we're going to go ahead and 4x squared. We got 4x and 1x, or just x if you want. We also have 2x and 2x. And we've got a couple of combinations there. 49, we have 49 times 1. And we also have 7 times 7. Now, if you've done these enough, you might start to recognize some patterns. This one here actually has a pattern associated with it, and this is what we call a binomial square. But for those of you that don't know, I'm going to actually go with the two numbers that are the same just to see if it works, because there's a good chance that it works out that way. So we have 2x, 2x. I mean, some people will say like it's equal probability, but in math, a lot of times for Algebra 2, we like to give you problems that have certain traits, and when you have the squares, that actually might be one that works. This right here is going to give us 14x. Oh, look at that. And notice this guy here, that's double the 14x, and that's exactly what you want to see. This is why we call it a binomial square. It's because it's the binomial times itself, right? So it's the same binomial twice. So we have 14x, 14x, and it looks like we need to add them, right? So we need to add them to get the middle number of 28, which it does. Now, since it's a positive 28 and we have the equal amounts, well, you need to have a positive 14. And then to get to up to 28, you need another positive 14. So we're going to say 2x plus 7 and 2x plus 7. Now we solve this thing here, and we're going to say 2x plus 7 is equal to 0. Since it is repeated, we don't need to say it twice. We're just going to solve it by subtracting 7 and dividing by 2. In other words, negative 7/2. Now, on the side, anytime a root happens more than once or a 0 happens more than once, sometimes I will write that it is a double root or a double 0 or a double solution. You don't need to do that, but that is something really, really useful when we get into chapter 4 and we graph polynomials. All right, if you have any questions, please don't hesitate to ask in class. The more questions you ask, the more likely you are to understand it after I go over. And if not, yeah, ask another question. All right. Other than that, I'll see you guys in class tomorrow. Have a great evening.